This is the Lewis structure part 2 video, and I'm going to focus on a couple more problems and a couple more examples, including ions, molecules that form chains, double bonds with oxygen, and sometimes where to place the hydrogen in molecules. Alright, so just as a refresher, here are the rules for drawing Lewis structures. Remember, we're going to count our valence electrons, determine our central atom, bond everything to the central atom, and then check the octet rule to make sure we don't need double or triple bonds. Alright, and this might help you out just a little bit. These are the numbers of bonds that the groups like to form. Alright, for group 1, it loves to form only one bond. Just like hydrogen, it loves to only form one bond. Group 4 likes to form 4 bonds. Group 5 likes to form 3 bonds. Group 6 likes to form 2 bonds, and Group 7 likes to form 1 bond. When you're drawing your Lewis structures, keep this in mind. Whenever you have something, try to make sure you make the appropriate places for making double or triple bonds. You don't want to really make a double bond with Group 7 because it only likes to form 1 bond. So try to follow this as close as you can. Alright, let's take a look at how to draw Lewis structures for ions. We're going to follow the same rules, except if it's a negative ion, you're going to add to the negative charge to the total number of valence electrons, but if it's a positive ion, you're going to take away the charge from the total number of valence. Alright, so let's take a look at the chlorite ion. Alright, let's go ahead and add up our total number of valence electrons. So we have chlorine is in group 7, so it has 7 valence. Oxygen is in group 6, so it has 6 valence electrons, but there are 2 of them. That gives me 12 plus 7, that's 19. And we got 1 electron right here, okay? We got 1 electron from the charge right here. Alright, so what you need to do is add how many electrons there are. So we have 1 electron for the -1 charge, so we add that to the total number. And that gives me 20 valence electrons. Determine the central atom, it's going to be chlorine because there's only 1 of them. I'm going to bond my atoms to my chlorine just like this and check to make sure you have 8 valence electrons around everything. Right now this oxygen only has 2, so let's go ahead and add 3 and 4, 5 and 6, 7 and 8. This chlorine only has 4, so let's add 4 more. And this oxygen only has 2, so let's go ahead and add 6 valence electrons around this oxygen. Now, let's check to make sure we have 20, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. We have 20 valence electrons. So this molecule is done, except since this is an ion, the only thing you have to do is enclose this in brackets and put the charge on the outside. That is how you draw Lewis structures for ions. Make sure you enclose it in brackets and put the charge on the outside. Let's take a look at the ammonium ion, which is a positively charged ion, or it's a cation. Remember, cations are positive. Alright, we have a nitrogen, which is in group 5. We have a hydrogen, which is in group 1, but there are 4 of them, so we add those up and we get 5 plus 4 is 9. Now, since we have 9, and look right here, the charge is plus 1, I have to subtract 1 total valence electrons. So we are up to 8 now. My central atom is going to be the nitrogen because it can never be hydrogen. And I'm going to bond all of my hydrogens to my nitrogen, the central atom. Okay, and I check to make sure everything has 8. Remember, hydrogen only wants 2. And right here, that's happy, 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 happy with its line. Remember, it does not want any valence electrons. It wants no dots, no double bond, triple bond, no valence, no lone pairs, nothing. It's just a hydrogen like this is fine. And the nitrogen has 2, 4, 6, 8 around it. It's happy. So this is a good molecule. The only thing is we enclose it in brackets, and we're going to put the charge on the outside. Alright, so that is the Lewis structure for ammonium. Alright, let's take a look at drawing molecules with chains. Oftentimes, if you see a molecule and you have a couple carbons in there or a couple nitrogens, they're going to form bonds with themselves or form chains. So for example, if you have something with 3 carbons, alright, it's going to oftentimes you're going to have the carbons bonded to each other, something similar to this right here. Same thing with the nitrogens. Oftentimes you'll see nitrogens, coupled nitrogens bonded to themselves as well. Alright, so let's take a look at a couple of examples here. So if we have C2H6, alright, change colors, I'll pick blue, and let's count the valence electrons. So carbon has 4, and there's 2 of them. That gives me 8. Hydrogen has 1, but there are 6 of them, so that gives me 6. I add that up, and I have 14 valence electrons. Now the trick here is we're going to bond the carbons together, and whatever is left in the formula, you're going to symmetrically, or as symmetrically as possible, bond them to those atoms that are connected in the chain. So I have 6 hydrogens, so I'm going to place 3 hydrogens on each carbon. Alright, and I'm going to place 3 over here. Okay, and let's take a look at this. Each hydrogen is good. 2, 4, 6, 8 around this carbon. 2, 4, 6, 8 around this carbon. And this is the correct Lewis structure for C2H6. Okay, let's take a look at the next one, N2H4. Alright, so nitrogen, it has 5 valence electrons, and there are 2 of them. So I'm going to have 10 from the nitrogens. And from the hydrogens, each one has 1, but there are 4 of them. Right here, remember, the 2 tells me I have that. The 2 tells me I have 2 nitrogens, and the 4 tells me I have 4 hydrogens. And that gives me 4, and that gives me a total of 14 valence electrons that I need. Alright, just like the carbons, the nitrogens are going to be bonded to themselves, and everything else is going to be bonded to the nitrogen. So I have 4 of them, so I'm going to split them up. I'm going to put 1 here, I'll put 1 over here. Let's do the same over here. So I put 1 hydrogen there, and I put 1 hydrogen right here. Check your valence electrons. I'm going to redraw this hydrogen. Doesn't quite look right. There we go. Oh, much better. That looks more like an H. Alright, and we take a look right here. Hydrogens are good. Nitrogen. 2, 4, 6. 7, 8. 2, 4, 6. 7, 8. Now let's check our valence electrons. This should make sure we have 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And we're good. So this is how you draw the Lewis structure for N2H4. Just remember, if you have N's or C's and a couple of them together, you could bond them together and form chained molecules. Alright, here's an example with a double bond and with oxygen. Oftentimes, if you have too many valence electrons in your molecule, remember, you're going to need a double bond. And just as an example, oxygen loves double bonds. So whenever possible, form a double bond with the oxygen and the central atom. Oxygen and the central atom. Alright, so let's take a look at this. We have hydrogen has 1 valence electron, phosphorus has 5 because it's in group 5, oxygen has 6 because it's in group 6, and we add that up and we have 12 valence electrons. Alright, so my central atom, let's see. Remember, it's the thing there's only one of, or the thing that's farthest to the left. Well, it's never this one. It's never hydrogen. That's in group 5, that's in group 6. Yep, 5 is more to the left, so the phosphorus is going to be my central atom. So we're going to have a hydrogen bonded to a phosphorus, bonded to an oxygen. And we check our valence electrons. Hydrogen is good. This needs 4 more. This needs 6 dots around it to make sure it has 8. And now we check our total. 2, 4, 6, 8, 10, 12, 14. Oh, darn. We have 14. So you know what that means. Got to make a double bond. Alright, and remember, to make a double bond, you take 1 lone pair away from each bonding atoms, and you put your bond in between. So let me rewrite this so it looks a little bit nicer. You have a hydrogen bonded to a phosphorus, which is doubly bonded to an oxygen. Alright, you just put your lone pairs that were remaining right there. And we're good. So let's go ahead and check it. 2, 4, 6, 8, 10, 12. And that is the correct Lewis structure for HPO. Alright, let's take a look at our last example for today. Alright, oftentimes what happens is you're not sure where to put the hydrogen, and oftentimes you're going to be putting it to the central atom, and that's going to be incorrect. Alright, let's take a look at this ion right here. Alright, so for this one, let's go ahead and count our valence electrons. So hydrogen has 1, phosphorus has 5, oxygen has 6, but there are 4 of them, so that gives me 24 valence electrons. So we're at 24, 29, we're at 30 right now. But remember, each electron for this charge right here, we have to add those, and there are 2 of them. So now I have 32 valence electrons that I'm going to be adding to make sure my molecule has 32. Alright, my central atoms, never hydrogen, too many oxygen. So let's put the phosphorus here. So the phosphorus is going to be in the center. And what's going to happen is the oxygens are going to bond to my phosphorus. Alright, now what's left is the hydrogen, where to place it. Oftentimes you're going to place it right here. That's a no-no. Don't put that hydrogen on the phosphorus. If you have hydrogen with oxygen in the same molecule, oftentimes it's going to usually bond with the oxygen. So what I'm going to do is I'm just going to pick an oxygen for it to stick to. I'm going to put it right there. You can put it to any of these 4. It does not matter. But I chose the hydrogen to go here. Just bond it to an oxygen. Alright, now what we're going to do is we're just going to check our valence electrons just to make sure we have 8 on everything, or make sure everything's following the octet rule. Alright, so this oxygen only has 2, so let's go ahead and add 6 more dots around it. This one only has 2, so let's go ahead and add 6 more dots around this one. This one only has 2, let's add 6 dots around this. And this one only has 4, 1, 2, 3, 4, so let's add 4 dots around this one. Remember, hydrogen, you leave it alone, it only wants the line. And let's check phosphorus. 1, 2, 3, 4, 5, 6, 7, 8. Phosphorus is good. Alright, so let's check, make sure we have 32. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. The only thing left is we need to enclose this in brackets because this is an ion. So go ahead, place this in brackets, and indicate the charge on the outside. And that's it. That's how you draw the Lewis structure for this ion and where you would place the hydrogen. Alright, now just so you know, this can be a little bit challenging at first, but once you get used to this and you do plenty of examples and you try and you do your homework, you'll end up being very good at this. So if it starts to seem confusing, please ask Mr. Clenchman or myself for help. We're more than happy to assist you. Just make sure you try, though. Alright, and remember, RST is every Tuesday and every Thursday, so please stop in after school. If you need help, please ask. Don't hesitate. Thanks for watching.